tool here. We can finally see if it works. We're gonna add 2024 day 1, and we are gonna try REXX. Okay, here we go. If all went well, the file should have been read in. Let's just print 3 lines just to be sure that it works. And we also already see it's our humongous numbers. So how are we going to get the smallest? They both just need to be sorted. Okay. Why? So we best add those lines in first. Oh, that's nice. Why does it do that? 1, 2, 3, 4, 5, 6. I don't think the spaces really matter. Three, 4, 2, 1, 3, 3, and the other end is 4, 3, 5, 3, 9, 3. And just to make sure we have 6 in our list. So it's list A and list B, basically. Where's my syntax highlighting? That's better. Put that there. That'll make life a bit easier. Call it list A. Left list. Okay. Left list. Let's call it list left. Dot. It's all zeros. Let me just write. It's also all zeros. We first need to make sure that though these go in the same thingamawigs. Right, so for every line we're gonna say parse var file dot I, and it probably looks like left item, right item. Yeah, and that is going to go in the list to the left and the list to the right, and our current items. Oh, that's just I. We don't need that. So let's just see if it works. Let us spell things correctly. Let's see. Our tries counter is. Well, that works. So then we can say that list left dot I equals left item, and list r dot I equals right item. So then at least we have them in those two stems, which we then need to sort. And I do remember doing a sorter in REXX last year, so why not try and find that for ourselves. If we can find it. No, it's probably in the advent of code things. So let's go and find it. I think it was last year. Yeah, day 23 last year. Maybe I can show it here quickly. That's how we done that. This is a very handy trick to copy into our current REXX. So let's give it some comments so we're clear on what we're doing. Go away. Sort the left list. So our sort string equals scorecode. Do I equals 1 to list left dot 0. Sort string, and we add the new line. And we add list left dot I. That gives us the, oh, we could probably do that in the above loop to make it faster, but that's alright. Then we can sort it out later, but well, let's first see if this works. Sort left equals echo. Hi. Echo. Sort string. And sort it. So we're going to fire that string into a Unix command to sort it. Maybe we have some errors. Not sure. Hopefully not, huh? Sorted. Comma, sorted. Looks like I'm missing a quote here for some reason. That looks better. Now do equals. So let's first see if it works. So remember, this gets the list 3, 4, 2. So we're expecting to see a 1, 2, 3, 3, 3, 3, 4. Or an error. Or nothing. Funny. Let's see what we run. Nothing. Oh yeah, we never put that length of that. Yeah. We created the new stem here, filled all the items of the stem, but we forgot to say that it's list L dot 0 equals file dot 0 list right dot 0 equals file dot 0. That's what we need as well. Otherwise, it has no items. Do it again. 1, 2, 3, 3, 3, 4. That's what we had wanted. That's good. So now we are sorting that list. I'm gonna have to do that with the right list as well. So we best make a sort L dot equals 0, sort right dot equals 0, sort L dot 0 equals file dot 0, because we're not losing items. We are not losing items. So here we're not going to say sorted.I, but here we're going to say sort left.I equals sorted.I. Now we can do the same for the right list. We'll repeat this entire chunk. This is more of the same. To the right, to the right. Okay, so now we have the two lists sorted. Back to our thing, and then we have to walk through them, go and how far the numbers are apart. Add up all the distances. If you pair up a 3 from the left with a 7, the distance is 7. If you pair a 9 with a 3, so it's the absolute difference. Yeah. And then we need to add them. Okay. That should be doable. Part 1 starts at 0. For do I equals 1, 2, sort R dot 0. No, let's just do files dot 0. That's how many we have anyway. Do we have an absolute in REXX? Sure we do. Absolute value, yeah. So we can say part 1 equals part 1 plus the absolute value of sort L minus sort dot I minus sort R dot I. So back to our, remember we're still running with our test input. We should get an answer of 11. So. Curious. Run. Aha! We get 6. That's nice. Check our thing again. 3, 4, 2, 1, 3, 3. 4, 3, 5, 3, 9, 3. 4, 3, 5, 3, 9, 3. So what did we do wrong? Let's do some checking, right? Say compare sort left dot I with sort R dot I. Just comparing 1 and 3, 2 and 3, 3 with 3, 3 with 4. We are missing our 9. Isn't that funny? Ah. Obviously need to start at the start. That was stupid. Oopsie. Maybe that. Oh. Yeah, because we're shifting bound by 1. Yeah. This makes sense. This makes sense. Totally makes sense. We need to go 1 to the left, and this needs to be a NI equals sorted. I think that will give us a much better solution. It should be better. Yes, it isn't. Ooh, what is going wrong? This needs to be I. Yes. Now we get 11. So we can comment out our test input, run it. Sub doesn't work for a REXX now, does it? We should have left this out, but hey, let's keep it exciting. See? Now we didn't even see the answer. So let's do it again. So we get a fairly large number that we can stick into our solution. First star is in. Now I'm worried about part 2. First. And I never switched the screen, so we'll go back here. It does yield 31. So it's pretty good. Part 2. We took our fake input. And here we just have the inefficient loop to go loop through the loop, loop through the loop the second time. So I think for our standard full file input we're gonna pay the price, but time will tell. Maybe it's time for a cup of coffee, huh? be worse. Oh, why does it say day 1? Because I ran day 1. It's gonna have to say part 2, so I need to run this one. It's a different number. So let's see if we were smart enough. Complete. Woo! See you tomorrow.